So let me begin by giving a small introduction to a few of the terms that I'll be using. The first term I want to introduce is multispectral image. So a multispectral image is an image that has a large number of channels or bands, and each of these channels are sensitive to different wavelengths of electromagnetic radiation. So if we consider a regular RGB image, for example, these RGB images have three channels, the red, green and blue channels, and we get this because the sensors are sensitive to these specific wavelengths. Similarly, we can have sensors that are sensitive to a wider range of electromagnetic radiation wavelengths, and because of this we are able to get multispectral images. The second thing I want to introduce is something called a remote sensing index. So a remote sensing index is a mathematical expression between channels or bands of a multispectral image. So for example, let's say we can have an expression like C0 plus C1. So here C0 is referring to the channel at index number 0 of a multispectral image, and C1 is referring to the channel at index number 1. So we can add these two channels to get another new single channel image, and this new single channel image is sort of the evaluated version of the remote sensing index. Now we can get into the problem. So the task that I'm addressing in this research is improving the segmentation performance of multispectral images. The way I am doing this or achieving this is by using reinforcement learning to generate the previously mentioned remote sensing indices. What I'm doing is I take this methodology and I apply it to the specific use case of serpentine zone segmentation, and we'll talk more about how that is. The reason for the hypothesis that remote sensing indices can improve the performance of segmentation is that there's a paper called MSNet, and this paper explores the usage of different remote sensing indices for improving the performance of segmentation, and they noticed that there is generally a good improvement in the performance. Now the task that we are doing here is we are generating remote sensing indices that are specific for the given segmentation task, and the process of this generation of remote sensing indices is done by using a reinforcement learning approach. So before I go into details about how I formulated this reinforcement learning task, let me give a brief introduction about what reinforcement learning is. So reinforcement learning is, for example, I'll give a commonly used example. So let's say we have a puppy, and this puppy, we want to train this puppy to sit, and we say the term sit, right? And but when we're starting out, the puppy doesn't know what sit means, so it will try different things. It will try jumping, it will try barking, and but that's not what we want. So until it sits down, we don't give it any reward. Now let's say it actually sat down. When it sits down, we give it a reward, and this reward can come in the form of let's say a treat, or we give it a pet, right? And because of this, the puppy will think, okay, when I sat down, he gave me a reward, and then maybe the next time he will just sit down for regardless of what command you give, he may sit down. And then when you are not given the reward, it will learn, okay, he only gave me the reward when he said sit and I sat down, and from there onwards he will learn to actually sit down. So that's the idea of reinforcement learning. You learn by experiences, and it's actually how we as humans also often learn. We learn by trying out different things. Let's say we accidentally touched a hot stove, and the second time we see a hot stove, we know, okay, let's not touch that because that hurts. And there we tried something and we got a negative reward, so we know, okay, that's not something we should do. So bringing back to the task at hand, what I'm doing is I have an agent, and you can think of the agent as the dog in the previous example. And in this example, or rather in this task, we want the agent to explore what are the different expressions that we can create, right? So there can be, in fact, if you're talking about an expression that has about 14 characters, this can extend up to about 10 to the power 17 possible expressions. So it's a very large state space, so we can't practically get the agent to explore all the different states. So because of this, what we do is we get the agent to learn what sort of expressions are good. So how the agent learns this is by going into these different is by generating different expressions, and after generating an expression it will evaluate, okay, will this be good for segmentation? If it's good, it will then, okay, this sort of expression is good for segmentation. If it isn't good, then it will learn, okay, this isn't good, I shouldn't go too much towards expressions that look like this expression. So that's the idea by which the agent learns, and gradually it will learn to get a good reward. And when we actually test this against the Serpentine zone segmentation label dataset, we can see that there is actually a somewhat significant performance improvement when they are using the remote sensing indices with our segmentation. So that's the idea there. So the first step would be to upload the dataset. Once you start up the application, you can come over to the datasets tab and then select your dataset from here. And once uploaded, you should be able to see the dataset at the bottom here on the dataset table. Then we can go to find expressions and select a dataset. So I select the one I uploaded previously, and from here you can click find expression, and from here on it will take some time, but after some time you will see the recently explored tree of different expressions. Okay, so after some time you will be able to see this UI, and from here you can see the latest expression tree. So the expression tree is denoting the tree through which you can generate an expression, and it shows all the different expressions that it has already explored and those that it hasn't. And from here you can get an idea of what sort of channel names are favored while what are not favored. Now currently the results aren't good. It's still giving a negative reward because the agent isn't trained yet properly. So with time the agent will begin to improve, and it will be able to get more positive results. And of the expressions that were generated so far, these are the best performing expressions that have been observed. And you can see the expression. So C6 SQ is referring to square, and SQRT is referring to square root. So root C6 is what's denoted here. So these are the currently identified best expressions, but there can be other expressions, or there usually is other expressions that have better performance. So the reward is mentioned at the end after the equal sign. Usually you are able to get higher and higher rewards as time goes on.